Okay, so let's now try to do another, computing the correlation coefficient problem again. And this time we have like somehow a smaller data set. Still, we have two data sets, right? But then the number of items is smaller. So first off, I know that the total data point is 5. 5 here is not that 5. Okay, it's just there are 5 of them. 1, 2, 3, 4, and 5. Right? And then for my x, the mean for all my x value here is going to be, let's say, once again, you can always pause this video here and compute the mean yourself while I'm doing it. So according to my calculations, my mean value for the x is going to be 3.2. Okay? And also I need to find the mean for all the y value. Okay? And according to my calculation, and once again, you must do this at the same time with me. And because I already have all that technology, so I can get it done pretty quickly. But for you, you can just go ahead and do it the same old-fashioned way I've showed you before. And so, I mean, to catch up with me here, you can always pause the video here and compute the mean value yourself. So, according to my calculations, my mean for all the y values is 7.2. And likewise, I have to also compute the standard deviation for all the x. And according to my calculations, once again, you should pause my video at some point and then do the calculation for all these standard deviations yourself also. So now my standard deviation here is a 1.92. Okay, and then also the standard deviation for my y values here is going to be 2.59. Right? And so once again, the way how to find the correlation coefficient, right? I have 5 total data items, right? So what I have to do is it's going to be 1 over 4 because it's always 1 less than 5. And then I'm going to go open a square brackets right here. And the first item is going to be, I'm going to have to look through my first item, my first x data, which is 1. I'm going to subtract from that the mean for x and divide it by the standard deviation for x to 1.92. Right? And I have to do, and then I'm looking down to the bottom to the y, and I'm going to pick the first item, 5 minus 7.2, which is the mean, divided by 2.59. Right? And I'm done for my first item. Now I'm going to go to my next item. Okay? The x here is going to be 2. And then I subtract with the mean value, 3.2, divided by the standard deviation, 1.92. Okay? And then times. And what I have is my y value, for my second data point, the y value here is going to be 4, right? Minus 7.2, which is just the mean value, right? And divided by 2.59, right? And then I have to do it again for my next one, which is 3 minus 3.2. That is for the x part. And then I have divided by 1.92. Right? Times with my corresponding y is 8 minus 7.2 divided by 2.59. Okay? And I'm going to add for 4 minus 3.2 again divided by 1.92. Okay? And then 9 for y minus 7.2 2.59. And last item I'm going to have 6 minus 3.2 divided by 1.92. Times with 10 minus 7.2 divided by 2.59. I'm running out a little space here. Okay? But then that's how I'm done with all of that. And so that's how you set up your ways to find the correlation coefficient, right? And then so now if you go through and do all that calculation, then your value here turns out to be my correlation coefficient is a Let me see. Okay, so my calculation this time. My calculation is a 0.80. It should be 0.898. Okay, and that is my R value. Okay, R equals 0.898. Okay, so this time, if you notice, the R value here is a lot larger. The R value here is really close to 1. That's what I'm trying to say here. It's a lot larger than 0, and it's really close to 1. So you can expect the expectation here in the graph. The expectation. Okay, the expectation. Okay. It's a positive correlation. Right? Positive correlation. Going up to the right. The trend is going to be going up to the right. Okay? So that's what happened. Alright, so now later on, of course, I'm going to show you how the graph of that's going to look like. Okay? So this is how we finished. We have completed finding our correlation coefficient.